All right, here we go. Welcome back to the Penny Math Teacher. So expectations are to use twice this video's length to actually take notes, pause, wonder, make sure you're annotating and adding things as you process them. Because if you see something like, oh, I got that pattern, or something that's really cool like that, make sure you're writing it down so later you remember it because you are awesome. All right. So here are our objectives. So I'm going to write these down actually as a whole unit. I think it's just simpler to see it as one big thing because this is a huge unit. You're learning about polynomials where you've just done linear things. We're drawing straight lines. This unit will be going into curves. You're looking at polynomials. Quadratics are the most basic polynomial because you're going from linear, which is a first degree polynomial, even though you didn't know about it, to a quadratic, which is a parabola or has one curve in it. If we up that, then we get more curves into cubes and quartic. We get more cubes, more curves in our functions. So we're going to work with polynomials. Then we're going to move into doing a lot with quadratics. We're going to graph them. And then we're going to solve them. And there's multiple ways that we can solve quadratics. Some of them are quicker than others. Some will always work no matter what. Others are really quick because it's a specific situation or a specific pattern that we look for, and that helps us. But that pattern may not always exist, so then we have to do the long way. So there's lots of different tools in our toolbox for that. Simplifying radicals, which helps us use the Pythagorean theorem. That gets you ready for geometry next year, as well as just recognizing how we can use that with quadratics, because the square root is the inverse of a square function. And then we're also going to factor polynomials, which helps us with solving. So it's kind of actually before solving, but I put it at the bottom just because there's multiple ways we can factor polynomials and break them down to then help us solve. So lots of objectives. Today's is just naming polynomials. Pretty basic, but because we are in a new unit, let me get our stuff up. We are in a new unit, so our table of contents, I filled up this whole first page, all right? I don't know about you in your notebook, but Systems has already moved us onto the back, and this is our whole unit. So it's a huge ton of videos just for this one unit, but you're also learning way more stuff than you did with just solving systems. So notice that it's longer. It is on the back, so I probably won't show you the front page anymore. I'm just going to go straight to the back and say, hey, here's our page, here's our concept, we're going. So, hey, here's naming polynomials, page 40, and we're going. Okay, I gotta go find page 40. There's page 40. Okay, so naming polynomials. So just a refresher, terms are always separated. I think I spelled that right. Separate. I didn't. I don't remember anymore. I think there's an A. I think it's an A. I fixed it on my paper, so I think it's an A. By addition or subtraction. And you can go further and say that terms are always separated by addition. It's just if you see a subtraction sign, that means that term is negative. So we will look into that, and you always have to keep that sign with the term. So for example, if I have 3x minus 5, this has two terms, but that 5 is a negative 5. So you could also write it as that and see the terms are still separated by the addition. It's just now we see the sign actually explicitly on that 5. So it's a negative 5, but a positive 3x. That would be two terms. And then degree means that it's the largest exponent. So we're going to make two different tables here. So if you want to see, we're going to make a table at the top and a table below that, and then we'll have some examples at the bottom. So our first table we're going to have is degree, name, and example. So we're actually going to use both tables to come up with a complete name, but we're going to have examples for each part of our examples in our tables. So the degrees, we can have a 0 degree, 1st degree, 2nd degree, 3rd degree, 4th degree, and then once we get to 5th plus, we don't have fancy names for them. So if you have a degree of 0, and if you remember, go back to our exponents booklet, anything to the power of 0 is 1. And since 1 has no variables, it's just 1, we call anything to the degree of 0 a constant. An example of this would be 3. Okay? That's a constant. There's no variables in there. All right, if it's 1, this is what we've worked on a lot this semester or last semester, wherever you are in the school year, is linear. So you could have the 3x minus 5 from above. That is a linear example because the degree is 1. So notice if the degree is 0, you don't see it. You could actually write this as 3x to the 0 because x to the 0 is anything to the 0 power, which is just 1. 3 times 1 is 3. I know it's a weird mental process, but this 3 is a constant because the degree is 0 on the variable. If you don't see a degree, it means it's 1. All right. 2, this is quadratic. So I could rewrite this as x squared minus 4x plus 1. All right, something along those lines. Doesn't matter how many terms. Terms is on our next table, but the degree is 2. If the highest exponent you see is a 2, this is called a quadratic. All right, and then cubic is if it has degree 3 as the highest degree. And I know I kind of skipped some lines. Quartic would be if your highest degree is 4. And then after that, we don't really, there's quintic. Yeah, there's fancy names, but we're not going to go into them all. So after this part, just say 5th degree or whatever nth degree you are in. So in this case, it would be a 7th degree if you want to put it that way. So anything 5 and above, just say the number and say that degree. All right, so then our second table is going over terms with the name and with an example. So for terms, you could have 1 term, 2 terms, 3 terms, 4 terms. 1 term is called a monomial. So for example, 3x. This is 1 term. You don't see any pluses or minuses. This is a positive 3x. If you want to think of it as a plus in front, you're welcome to. But there's no other terms there to be separated from. A binomial, like a bicycle, binomial, would be 2y minus 4. 2y minus 4. 2y and a negative 4. Those are 2 different terms. And make sure that 4 is negative. Trinomial, x squared plus 3x plus 9. And then anything 4 or above is going to be a polynomial. Okay, now this does get a little misconstrued. And there is an extra definition in here that I'm not going to mention explicitly in our notes. But notice that all of these do not have any variables in the denominator. They could themselves be a fraction. So if I'll use blue, why not? And make sure this can write. There we go. So this, if I had 3/5 x, that would still be a monomial, right? But because the x is technically in the numerator, that 3/5, that's fine as being a coefficient, but just make sure that you don't have any variables in the denominator. That is no longer a monomial. And polynomials are made up of monomials, but then still kind of encompass everything. So binomial could still be called a polynomial, and same thing for a trinomial. But if we're specifically classifying and naming them, then polynomial would be 4 or more because we have special names for the 2 terms and 3 terms. On that note, I do want to go back, and actually we're going to make an extra column, an extra example column of naming these. So if I look at this, just this 3, I know it's constant, and how many terms are there? There's only 1. So this would be called a constant monomial, because the degree tells me it's constant and the number of terms tells me it's a monomial. So whenever I name a polynomial, and all of these are generically called polynomials for the sake of this unit, I'm going to name it by the degree and by the terms. So it's going to get two different names on it to make the complete name. For space's sake, I'm going to come down here to the quadratic. There are 3 terms, and we're going to deal a lot this unit with quadratic trinomials. Okay, that is going to be the most common type of polynomial we're going to work with, but knowing what a quadratic trinomial is going to be very helpful, because it means right away you're going to know it's a degree 2, so I already have these tools in my toolbox, and it's trinomial, so it has 3 terms, so I need to know these tools in my toolbox, because sometimes you will get a quadratic binomial, and that's a little bit different because we're going to use a little bit different tools, even though it's the same concept, overarching concept that's in this unit. Quartic would be a quartic binomial because there are 2 terms there. This would be a 7th degree binomial. Think about it. What would this one be? This would be a cubic binomial as well. This would be a linear binomial. All of those only have 2 terms, so they're all binomials. If we move on down, here's another quadratic trinomial, and this is a cubic polynomial because there are 4 or more terms, and the highest degree, or the highest exponent, which is called the degree, is 3 for cubic. Okay? So I do want to do a couple examples below here. So in our 3 examples, our first one is -7 plus 3n cubed. All right, so notice that this is not in standard form. If you've looked at all of our past examples that I wrote down, those are all in standard form. They start with the degree and work down. So in standard form, this is actually going to be 3n cubed minus 7. The name of this would be a cubic binomial. Okay, so know what standard form is and how to name it. We're going to combine all of that into this one lesson. 5 is actually going to be the same as up here. It's going to be a constant monomial. All right, so if you want to write that down, you can. We'll just draw an arrow up to that example. 3 would be -x to the 4th plus 3x squared minus 11. So even if I'm missing a cubic term and it's not going 4, 3, 2, 1, 0, it's just going 4, 2, 0, that's totally fine. This would still be considered a quartic trinomial, and I'll put constant monomial up here as well. So we're going to start using this vocabulary in each of our lessons. Make sure that you understand how we are naming things and what they even mean, because we're now going to move into comprehension questions, and most of these don't affect you for this lesson. So just an FYI, it's okay if these confuse you, but I want you to look at them, get familiar with just reading these words, even if you have no clue what they mean yet. We will go over them, so just know what's happening and coming forward. All right, so thank you for spending your time with me today, and have a great day.